Hi guys, welcome back to my channel, like literally after a long gap. And those who are new here, hi, I'm Ankita and I make educational content videos. So my last video was on December 2021 maybe. So it's been almost a year I haven't uploaded any video because life has been so hectic recently. Like I completed my masters on 30th May, then on 2nd June I joined as a PGT physics teacher in a CBSE affiliated school near my hometown, and simultaneously I'm preparing for my PhD. So I don't know how to manage time, like I don't know how to give time, how to invest time on my YouTube. So life has been hectic, no doubt, but at the same time I was sad that my channel got freeze. But let me finish. Yesterday I started physics practical for class 11 student, and then I thought that yeah, I can make a video on how I mentor my student while doing physics practical, because it would be cool, right? Yeah, I know it would be cool. Yeah. So here I am today with a video on how I mentor my student while doing physics practical. So today's practical will be on Vernier caliper, like how can we measure the thickness of an object, how can we measure the external thickness, internal thickness, depth of an object using the Vernier caliper. So firstly I'll discuss about what is a Vernier caliper, its full description. Then I'll move on to the how can we measure the thickness using the Vernier caliper. Then I will give you all a demo practical class with my student on how we can do the practical, how I mentor my student, how can we measure the thickness using the Vernier caliper. Yeah, without any further delay, let's start.
This is the actual Vernier caliper, like this is the movable jaw, and this is the external jaw. External jaw is used to calculate the external diameter of any object, and this is the internal jaw. This is the internal jaw, which is used to calculate the internal diameter of any object, and this is known as the stem. Stem is used to measure the depth of any liquid or something. Okay, so let me now show you how we can measure the external diameter, internal diameter and depth of any object. So if I want to measure the external diameter of this beaker, so with the help of the external jaw I can easily measure the external diameter of this beaker. So as you can so how we will read the reading, as you can see clearly, we will see for the main scale reading, we will see where the zero of the Vernier scale is coinciding with the main scale. So as you can see clearly, it is in between 6.6 to 6.7, so its main scale reading will be 6.6. So for the Vernier scale reading, I'll see which there are 10 division, right? So which number of division of the Vernier scale is completely matching with the main scale. So as you can see clearly, the third line of the Vernier scale, there are 10 line, right? So third number division of the Vernier scale is completely aligning and matches with the main scale reading. So the Vernier scale VSR reading will be 3 into its least count. So that's how we can calculate, and I'll obviously show you like how we can measure the diameter of a spherical body. So this is just to show you that how we can measure the external diameter. And if I want to calculate the internal diameter with the help of external jaw, we can't calculate the internal diameter, right? Because I have to exclude this part, right? So with the help of this internal jaw, as you can see, with the help of this internal jaw I can calculate the internal diameter of this beaker, and with the help of this stem I can measure the depth of this liquid. So that's how you can use Vernier caliper for multiple use. So as I have already shown you guys the main structure of the Vernier caliper, like the use of this external jaw, which is obviously used to measure the external diameter of any object, and the use of this internal jaw, which is used to measure the internal diameter of any object, like to measure the internal diameter of any beaker or something, and this stem, which is used to measure the depth of any liquid in a beaker. And this is the main scale, and which is used to measure the main scale reading obviously, and the smaller one is known as the Vernier scale reading. Main scale is a centimeter scale, like the normal meter scale. This is similar to the normal meter scale, and the Vernier scale, which is the smaller one, is the millimeter scale, because the 1 division in a main scale is equal to the complete 10 division in a Vernier scale. So obviously this is the millimeter scale. Now let me show you guys how can we measure the depth of like how can we measure the depth or any diameter of any object, like the main calculations, how can we measure the error calculations, and how can we measure the corrected measurement with error calculation. So let me show you guys that. So the initial step of any calculation is to calculate the least count of any instrument. By the least count we mean that the smallest value our instrument can measure, like the resolution of any instrument. So the least count of the vernier caliper can be measured as you can see that this is the main scale and the smaller one is the vernier scale. So the least count of the vernier scale is least count, LC, equals to pitch divided by number of division on vernier scale. So the pitch means, as you can see that, say suppose this is the main scale and the smaller one is the vernier scale. So pitch means this is mean as the pitch. So since this is a centimeter scale and the vernier scale is a millimeter scale, so the pitch is the unit of one division. So this is 1 mm divided by the total number of division. The total number of division in a vernier scale is 10. So the least count of the vernier scale is 1 mm divided by 10, which is 0.1 centimeter, divided by 10, which is 0.01 centimeter. So the least count of a vernier scale is 0.01 centimeter. When you can measure the diameter of any object, it can measure up the value up to 2 decimal, like 12.52. So it can measure up to 2 decimal in a vernier scale. Like you can't measure 12.521, you can only measure 12.52, 12.53, 12.54, or like that. And so as we have already studied in chapter 2, right, there are different types of errors, because while measuring any object or any something, we can't get the result with perfect accuracy, because nothing is perfect, right? This is true, nothing is perfect, and to get error is very much normal. So due to instrumental error or something, or due to manufacturing defect in the instrument, it is normal to get error. So the errors in the vernier caliper is zero error. Zero error means due to manufacturing defect or something, the zero of the main scale, suppose this is the main scale 2, 3, and this is the vernier scale. So the zero of the, this is the main scale, this is the vernier scale. So the zero of the main scale sometimes doesn't coincide with the zero of the vernier scale, and when the zero of the vernier scale moves ahead, like moves right hand side, this is the main scale and this is the zero of the vernier scale, it moves ahead of the main scale, then it is known as the positive zero error. And when the zero of the vernier scale moves or backward, or it's lag behind of the main scale, then we call it as negative zero error. Now how can we calculate the zero error? You will calculate the zero error and with a positive sign, and when the zero of the vernier scale moves backward, like it lags behind of the main scale, then it is called as the negative zero error. So zero error, its calculation will be zero error with a negative sign. So how can we calculate the error? Error equals to difference into its least count, right? So the difference will be, suppose this is the positive error, right? So here, as you can see, this is the positive error, this is the main scale, zero of the main scale, and this is the zero of the vernier scale. The zero of the vernier scale moves ahead of the main scale, so obviously it will be positive zero error. And here we can see the 6th number division is, then to calculate the difference we will see which number of the vernier division is coinciding with the main scale. And as you can see properly that the 6th number division in the vernier scale, like the 6th number division in the vernier scale, is completely coinciding, is completely aligning with the, matching with the, this is the main scale reading and this is the 6th number division of the vernier scale. So this is completely matching, or this is completely aligning with the main scale. So the difference will be 10, the total number division in the vernier scale, minus 6 into its least count, which is 0.01 centimeter. So 4 into 0.01 centimeter, which is 0.04 centimeter. So the error in the vernier scale is 0.04 centimeter when it is showing a positive zero error, and when it is showing a negative zero error. Since it is a positive zero error, it moves ahead, so you need to subtract that thing, right? And when it is showing a negative zero error difference into least count, suppose in the same way it is aligning in the sixth number of division, so 10, but it is showing a negative zero error, 10 minus 6 into its least count. So 10 plus 6 into its least count, so which will be 16 into 0.01, 0.16 centimeter. Since it is moves backward, it lags behind, so you need to add that thing, right? So this is how you can calculate the error. The corrected result or the final result is calculated as corrected result equals to observed value. Observed value is obviously what you have calculated from the table, like as we have already studied in chapter 2, units and measurement. Measured value equals to a mean plus minus delta a mean. A mean is the mean value and delta a is the obviously the error, absolute error. So here the observed value will be what you have calculated from the table, the mean average value, then plus minus its error. So when it is showing a positive zero error, so suppose the observed value is 1.75, so 1.75, since it is showing a positive zero error, so you need to subtract that thing, right, since it is moved ahead, so 0.04. And when it is showing a negative zero error, 1.75, since it is moves backward, it lags behind, so you need to add that thing, right? So 10 plus 0.06, which is 0.16 plus 0.16. So this is how we can calculate the diameter or depth or internal diameter of any object using the Vernier caliper. Okay, now let me show you how I mentor my student in measuring the diameter of a spherical body using Vernier caliper. And now Abhijit and Vidyanov will show you how we take the measurements. So Abhijit, what you gonna do?
I am going to measure this spherical body by using the Vernier caliper.
Yes. And Vidyanov, why we are using this Vernier caliper? Like we can use meter scale also, right, to measure the length. So why we are using Vernier caliper?
Ma'am, as we cannot measure the spherical ball in the meter scale with accuracy, we will measure the Vernier.
Yes, we can't measure spherical body
yes,
using
ma'am.
meter scale,
Yes,
right?
ma'am.
Yeah, you're right.
We will. That's why we are measuring the spherical ball in the Vernier caliper.
Yes. Okay, now show me, you two, how we take the measurements in Vernier caliper.
First, we have to open this movable
Yes.
jaw, and I will grip this spherical ball.
Yes. Then you tight the screw so as to fix the position. Yes.
Now we'll measure the is 1.8.
1.8.
1.8.
1.8 or in between 1.7 or 1.8?
It is between 1.7 and 1.8.
Yes, which is what? MSR reading, right?
Yes,
Main
MSR
scale
reading.
reading.
Yes,
So
main
main
scale
scale
reading.
reading is where the Vernier scale, 0 of the Vernier scale is coinciding in the main scale, that is your main scale reading.
Yes, yes.
So it is 1.7.
1.7.
So we will take 1.7 since it is in between 1.7 and 1.8. So we will take 1.7, yes.
Yes.
Then Vernier scale reading,
And Vernier scale reading is
which in Vernier scale reading you will see which number of division in Vernier scale is coinciding, aligning with the main scale. So
Yes.
which number? See clearly.
1, 2,
Because
3,
due to parallax also we can get error, right? So see clearly.
1, 2, 3, 4.
4.
Yes,
Okay.
4 now.
So Vernier scale reading will be what? 4 into
Into
its least count.
least count.
Least count is
0.01.
yes 0.01
centimeter.
centimeter. So 0.04
4
centimeter.
centimeter.
So total reading will be MSR plus VSR. So which will be 1.74
4
centimeter.
centimeter.
Right?
Yes.
So similarly, Vidyanov, you take another measurements. so that we can take several measurements. MSR will be 1.7 because most of the
Yeah, 1.7 on them.
There will be a slight variation with VSR. 1.7. Then you check which number of Vernier scale division is aligning.
5, ma'am.
5.
Yes, ma'am.
Okay. Then 5 into its
0.0.
Yes. So 0.05 centimeter. So 1.74. So similarly, we have to take several measurements.
Yes.
Then we have to take average. So average will give the true value. Right.
Yes.
Then we will calculate the corrected value. Corrected value is what? Average value plus minus
plus
is
minus
zero
zero
error.
error.
Yes, correct. So that's how we can calculate the measurements. Okay. Thank you. Vidyanava Navijit.
Thank you, ma'am.
Thank you, ma'am.
So yes guys, that's it. If you really like this video, then do share with your friend who are suffering with doing physics practical, and do like this video, do subscribe to my channel if you really want to, and help the YouTube algorithm to pop up my videos more. And I'll see you guys in my next video, which I don't know when. Till then, take care and bye bye. And yes, I'll try to be consistent.